Hello everyone, my name is Yogesh. I'm your data scientist. Today I'm going to look at visual analysis with R using automobile dataset. Before that, I thought to give you a quick overview of what RStudio is. So you can see there's four boxes, four environment, as you would see. So this is like source files. So for example, if you were to write source code R source, you would save it here, and when you run, it runs into console. Then any variables you create, as you will see in this tutorial, you will be able to see all the variables created here. Then the actual plots, actual graphs will appear here. So there's four parts to RStudio. So I'm not sure whether I have covered or not, but this is just a quick overview. Let's dive into our data set. So before that, before anything else, first thing first is we need all these packages. So pplyer, gplot2, reshape, then call that into as library. I've already installed it, so I'm just going to call these libraries. Then I need to change the data source of it. So the first I will clear the lists memory. Then I have already located that file here. It's got a zip file. Within that zip file is the CSV file, which is vehicles. Let's have a look what's in the actual data set. Let's see. Okay, so we've got quite a good number of variables here. Let's look at variables in its type. We've got about 74 variables and about 34,287 observations, which is when we say observation means records. When we talk about variables means columns. Those who are familiar with SQL Server and so on and so forth. Let's dive into this. And there's another file called labels, so which has all the labels explained. Let's see, as you can see here, it has created the variables, and if I was to click that, you would see all the variable names and the data set here. So this is why it's quite good, handy tools to have a global environment where you can see as you go along and create different variables, you can see the output itself, which is quite handy, I think. So let's close this and let's have a look ahead. So let's have a look at number of rows in vehicle. So there are, as we mentioned earlier, that it's got 34,287 rows, 74 columns. So there are how many vehicles types in there, and let's see how many unique vehicles across years. So there are 31 different types of vehicles recorded in this data set. Let's check first year. So we have created first year, you can see, and let's create last year, and create length of unique, then put that into as a table. Let's find out what type of fuels are used as the automobile primary fuel type. So what are number of cars which are using different fuels type, for example diesel, petrol, electricity, so on and so forth. So there are, in this data set, we've got about 1,000 cars which uses diesel. On the other hand, there are about 56 uses electricity, and 41 gasoline, 57 natural gas. About 8,500 of them uses premium gasoline, and the regular one, regular gasoline is about 24,000, more than 24,500. So let's have a look another. Now let's explore the type of transmissions used by these automobiles. We first need to take care of all missing data by setting it to NA. So this is very good practice when it comes to cleaning your data. The first thing you would do in data science is to observe data and to clean data, ETL, extract, transform, load, so on and so forth, to make sure that data are cleaned, and when you analyze, it's not skewed, or it doesn't give you kind of two weird numbers. So in this code, what we're trying to do is we're trying to see how many numbers of cars are automatic and manual. So there are about 22,000 automatic cars, and about 11,000 are about 12,000 are manual cars. So what does this code do? So what this code does is it looks at overall trend of how MPG, mile per gallon, changes over time on an average. So to do this, we first need to load dplyr library and from pplyr package. So we have already done that over somewhere over here. So now, so let's see what does it do. So I reckon you should produce a graph, yeah, something like this, which gives you kind of time series analysis of average mile per gallon. So you can see from since the first data point, it dips in, then in just around 1995 to 1999 it picks up, then goes down again, then again in from something like 2006 or 2005 picks up quite significantly, quite steep steep uprise, steep slope. So to gain better understanding of this new data frame, we pass it to the gplot function, telling it to plot AVG and plot this graph nicely and smooth. So then what we do is we call that variable, and so if you want to look at that variable, we can see here labels, variables, all that created here. Then now let's look at, it's obvious that one might conclude that there is tremendous fuel consumption in last 5 to 7 years. You can see here, but let's look at closely what it is. So one could easily misunderstood this graph by saying there are lots of fuel consumption, but bear that in mind that there are some non-gasoline cars came out just after 2010, and also some hybrid cars. So which is, we want to see why is this all of a sudden in a peak. So to do that, we we pass that onto we create a new variable called guess car. What it does is it creates a subset of these and says, give me all these cars: regular car, premium gasoline, mid-grade car, so on and so forth. And the fuel type is not like hybrid or anything else. So let's have a look what it does. And when we plot, you can see this graph is slightly clear, but let's see. I think I know why I had that error, because there was so this I had pushed down this to the next line just to make it more clear. It's quite getting longer, but if you were to put that into one line, should work, and it gives us kind of scatter plot with a blue line, and you'd see there's like small prediction as well, forecasting as well. So it's saying, what does it tells us? It's saying fuel, again, consumption's going down now. So this is quite strange, isn't it? So now let's see whether more small cars were made in later years, so just after 2005 2010 onwards, which can explain this drastic increase in fuel efficiency or fuel consumption, as we saw earlier graph. So let's look at that. Yeah, it gives me error because, as I said, it needs to be on one line. So I'll just push this, and it should work fine, just fine. Okay, so this is a bit more interesting. From the figure, from this chart, what we see is the average engine displacement has decreased dramatically since after 2008 or so. So you can see it's diving. So to get better sense of the impact this might have had on fuel efficiency, we can put both MPG and displacement by year on the same graph using ddplyr. We can then create a new data frame called by year, which contains both the average fuel efficiency and average engine displacement by year. So let's do that. So how do you do that? So no, this is here. Okay, so what does it tells us? It tells us the average mile per gallon and average displacement for first 6 years. But if you were to click average car, by year, it will give you all the years and average mile per gallon and average displacement. This is the really handy tool I use all the time. Just when I create a variable, I just need to go in and check what are the numbers just to get a sense of. So really handy tool this is. Let's create another variable called year. So what it does is it gives you the exactly same values of average mile per gallon, but at the same time it creates kind of a variable within, and say assigns a value, text value, string value called average MPG, which is we'll be using later on. Let's plot this graph, see how it looks like. So it gives us two graphs. Which the first one is average mile per gallon, and the other one average engine displacement. So What can we say from this graph? So from this graph we can conclude that the engine size has generally increased um, until 2008. So engine size has increased until 2008 with sudden increase in larger car between 2006 and 2008. So from here to here it increased quite a lot. Since 2009 has been a decrease in average car size, um, which partially explains the increase in fuel efficiency. So in 2009 there has been decrease in average car size. So you might see that's why it's kind of peaking. So it's kind of good solid slope increase, straight increase. Until 2005 there was an increase in average car size. So until 2005 there was increase in average car size, but then the fuel efficiency remained roughly constant. This seems to indicate that engine efficiency has increased over the years. So definitely engine efficiency has increased over the years. The years 2006 and 2008 are interesting, though the average engine size increased quite suddenly. The MPG remains mile per gallon remained roughly the same as in the previous years. This seems discrepancy might be more requires more investigation and more deep dive into it. Given the trend towards smaller displacement engine, let's see whether automatic or manual transmissions are more efficient or four-cylinder engine, and how that efficiency have changed over the times. Let's have a look. So you can see this box whisker plot. Just to zoom out so you can see properly. Okay, so this is automatic cars and this is manual cars. So you can see in manuals there's quite number of outliers, quite significant numbers of outliers, whereas in automobile it's quite few outliers here in between, and whereas in manual there is no outliers at all after 2009. It's quite a surprise, but we can deep dive into and see what that is. So now let's look at the changes in proportion of manual cars available each year. So to do that, so you can see each year number of cars available, transmission. So as the year increases, the automobile increasing, you can see, and the manual kind of going down. If you see Stackgraph, you can see the red is automobile, and the other one is manual. So manual is kind of decreasing on, whereas the automobile is on rise, which is I think fair forecast. So what do we conclude from this stack graph is it appears that manual transmissions are more efficient than automatic transmission, and they both exhibit the same increase on an average since 2008. However, there is something odd here. There appears to be many very difficult cars, less than 40 miles per gallon with automatic transmission in later years, and almost no manual transmission cars with similar efficiencies in the same time frame. That is, the pattern is reversed in earlier years. We can ask a question like, questions. For instance, is there a change in the proportion of manual cars available each year? Yes. What are these very efficient cars? In the next section, we will look at the makes and models of cars. So let's have a look at that in part 2. This is part 1 finished, complete. Part 2, let's look at creating a model and a make of cars and models of cars.